I'm going to go over the basics of static electricity. So static electricity was first noticed a very long time ago. It was found that when fur was rubbed against amber, the amber would be able to pick up some small light objects. Now, they didn't know exactly what that was, but that is the origin of charge. Now, much later, it was found doing experiments that if we have two different kinds of rods, one amber and one glass, they were able to find that sometimes they would repel each other, that's pushing away, and sometimes they were attracting each other. Now, what kind of charge they each had may not have been exactly known, but it led to the conclusion that there were two different kinds of charge, one that would attract and one that would repel. So where does this charge come from? Again, going back to chemistry, you should remember that atoms have neutrons and protons in the nucleus and electrons outside the nucleus. The protons have a charge that is positive, and electrons have a charge that is negative. Now, the electrons are located on the outer edge of the atoms, and they can be moved. At least the valence electrons can be moved. If we have extra electrons, then we are going to have an atom with a negative charge. If we have electrons that are stripped away, the atom is going to become positively charged because we have more protons than electrons. Now, the same thing is true of materials, not just atoms. Now, one thing to know, when we talk about charge and things that are moving around, being stripped away or added, only the electrons can move. The protons are stuck in the nucleus and cannot move. All right, overall, the world is filled with electrical charges. But overall, most things are going to have an equal number of positive and negative charges, and they are called electrically neutral. So when we say electrically neutral, that just means the number of protons, the positive protons, is equal to the number of negative electrons. When we say something is negatively charged, it doesn't mean that there's only negative electrons. It just means that the number of protons, the positive charges, is less than the number of our negative electrons. And if something is positively charged, again, it doesn't mean that there aren't any electrons. It just means that there's more positive protons than negative electrons. So static electricity is when we have a buildup of this electric charge on the surface of an object. With static electricity, static means not moving, so the charge builds up but does not move. Static electricity is a form of potential energy. It doesn't move, it is stored. Now, with electric charge, in general, if you have charges that are the same, so with these protons and neutrons, we've found that if we have two positive charges, two protons, they are going to push away from each other. And if you have two negative electrons, the two negative electrons will push away from each other. But if we have positive and a negative, opposites, they are going to be attractive. Now, in your notes, there is a space for you to do an experiment with tape. So please just skip that chart and the first question on the next page. All right, so the next thing about electric charge, and we will do the demonstration that leads to this, is that we also have a situation where neutral objects are also attracted to a positive or a negative. So if something is neutral, that means it has an equal number of protons and electrons. It can be attracted to either a positive or a negative charge. So if we have things positive, negative, and neutral, and they're attracted, how do we know if they have the same charge or opposite charges because of that neutrality? Well, the truth is you don't. You only know that two charges are the same if they repel. If they are attracted, they could be opposite or one could be neutral. So you have to have more information in order to be able to determine which charge something is. So, for example, if I just had balloons B and C, right here, I wouldn't know whether B was positive or neutral or C is positive or negative or neutral. I can't tell anything about that charge without more information. So looking at this problem, and you're going to get some of these on your assignment, we have 3 balloons that are hung from the ceiling by threads. Balloon A is positively charged, so balloon A has a positive charge, and balloons A and B repel each other. Well, since they repel, that means balloon B also has a positive charge. So balloon B has a positive charge. So that tells us what the charge on balloon B is. But C then is attracted to balloon B. So without further information though, I can't tell whether or not C is neutral or whether or not C is a negative charge. So the more information is going to come from this part right here. It says that balloon C can attract neutral bits of paper. Well, neutral cannot attract neutral. So if C is attracting bits of paper, it must have either a positive or negative charge. Well, if C is attracted to our positive B, then it has to have an opposite charge. So C is going to have to be negatively charged. So you have to have all of this information to try and work out exactly what the charge is on C. All right, so how exactly can neutral objects be attracted to both types of charged objects? The reason is something called charge polarization. Basically, I'm going to pull up a simulation to explain this. All right, so this simulation is going to show how you can have, how neutral objects can be attracted. So right now we have a balloon, we have a sweater, and we have a wall. And the balloon and everything has a neutral charge to it. Well, I'm going to take the balloon and I'm going to rub it against the sweater. When that happens, the balloon is going to remove the electrons from the sweater. And so now the balloon has a negative charge and the sweater has a positive charge. And if I release the balloon, it's going to stick to the sweater because they have opposite charges. But what happens when I bring the balloon next to the wall? The wall is neutral. Now the balloon has negative charges, so watch what happens as I bring it close. Notice how the negative charges start to move away from the balloon. The negative charges don't want to be anywhere near the other negative charges. They are repelling each other. So the negative charge of the balloon is going to push the negative charges away, and it's going to leave that area of positive charge. So now we have a positive charged portion of the wall and a negatively charged balloon. And so now they'll be attracted to each other and they'll stick. This is called charge polarization. So this is based again on the fact that as electrons collect on something, it becomes negative and it leaves a positive charge. And of course, remember, opposite charges attract, like charges repel. So what causes static electricity? Static electricity is caused when 2 objects rub against each other and electrons transfer and build up on an object, causing it to have a different charge from its surroundings. That was just like the balloon rubbing on the sweater. So it's also the same as shoes rubbing against carpet. When you walk on carpet, your shoes rubbing against the carpet, the electrons are ripped off the carpet and transferred to your shoes. Now then, what is it that causes you to be shocked when you go near a door handle? Well, when you go near that door handle, a door handle is a conductor. And so you have a buildup of negative charge on your hand, and when you go near the door handle, that is a convenient place to release those electrons. And so those electrons are going to run into the door handle, and that is where you get an electric shock. So an electrical discharge is the passing of an electrical current through the air from a negatively charged object, your hand, to a positively charged object, the doorknob. And this is also what causes lightning, which we'll go into in a moment. Another example of this is the static electricity, or the static you get when you take clothes out of the dryer. So what's really happening is as the clothes are tumbling around in the dryer, some of them are ripping electrons off others. And so you get some clothes that are positively charged and some that are negatively charged. And then you get them attracting to each other, and so you get everything sticking. And dryer sheets can help keep that from happening. All right, so how about lightning? What is it that causes lightning? Well, lightning happens when we have clouds. Clouds are formed with a lot of particles of ice. And as those particles of ice are moving in the air, they collide with each other, they rub against each other, and some of them become positively charged and some become negatively charged. Now within clouds, the positive charges tend to rise up towards the top of the clouds and the negative charges tend to congregate near the bottom. What happens then, just like that charge polarization we saw, those negative charges at the bottom of the cloud are going to push the negative charges away from the Earth. And so we are left with a positive section right here, and we have the negative part of the cloud here, and when the buildup is strong enough, that's when you get a lightning strike. Now, we're moving these negative charges now over to the sides, and eventually we can also get these positive charges over here and the negative charges down on the ground, and there's also going to be a lightning strike going this way. Now, when it's going from what's moving again is the electrons. So from the bottom of the cloud to the ground, the lightning is going to start in the cloud. From the ground to the cloud, however, the lightning is going to be moving from the ground to the cloud. It's going in the opposite direction. Now, you can also get cloud-to-cloud lightning. But this is a video of lightning that is going from the ground. So this was taken in Kansas. But that's showing lightning that is going from the ground up towards the clouds. So lightning can travel both directions. And that's it.